Hello and welcome to this session. In this session, we look at the serialized file formats, and before that, let's understand what is serialization. So, serialization is the process of converting a data structure or an object into a format that can be easily stored or transmitted over a network, and it can be easily reconstructed at a later point of time. So, that's the definition of serialization. But let's break this down. So, what exactly do I mean by converting a data structure or an object, blah blah blah? So let's understand that particular. So let's break this down and understand it in a simpler way. So what is happening here is we have a data. This is in normal text format or something which is readable format. Now what we can do is we can serialize this data into streams of bytes. So what you are converting this readable data into bytes, streams of byte, which is unreadable. So this process is called as serialization. Now, why we need to do this? What is the advantage? One, it is easier to transmit this data over a network. So when you send the serialized data over a network, it is easy to transmit, it is easy to move around. The second advantage is the compression techniques, right? So you can compress the data to a good degree. So that's the advantage. That's the reason why we do the serialization. Now, once you serialize the data, this is again in unreadable format. So at the end, you will have to deserialize it. So when you're converting the streams of bytes or serialized data to its original form, that is called as deserialization. So this is the concept of serialization. First, we serialize the data so that it is easy to get transmitted to the endpoint, and once it receives the endpoint, we have to deserialize this data so that it can be easily readable. Now, you don't have to do anything extra for to deserialize or deserialize. We have different file formats which is used for serialization, and then you have different programs which will internally deserialize it when you are querying this data. So these are basically the advantages that I mentioned. So it's easy to transmit over a network, and reading and writing is going to be fast. They are offer good compression, and again, this deserialization is something which is not going to take much time. So basically, it's a good practice to serialize the data, especially when you have huge data, right? So these are the serialized file formats that we have in big data. So we have sequence file format, the RC file format, the ORC file format, Avro, and Parquet. Now in this, sequence and RC file format are kind of an extinct. They are not used much in the projects. The remaining three file formats, the ORC, Avro, and Parquet, are used very extensively and for different use cases, right? So let's understand what is sequence file format. So sequence file format is basically a pure Java serialization. So it helps in easy retrieval of data. But this is, as I mentioned, this is just Java serialization. So it works best for MapReduce only. MapReduce is built on Java. So if you want to use MapReduce, you need to learn Java. Now, because we have many other programs like Spark, we can do Hive. We don't, most people don't rely on MapReduce, and that is also something which kind of becoming extinct. It's not obsolete yet, but there are projects, a few projects which still use MapReduce. They haven't migrated to Spark, but over a period of time, that is also going to happen. Because of that reason, now because MapReduce is not something which is extensively used, you will not see this sequence file format being used that much. So that's about the sequence file format. The next is your RC file format. This is row columnar file format. So writing in this format is going to take time. So writing is kind of a headache, but reading wise, it's going to be fast. They are easy to read. But RC file format actually does not offer any compression here. So if you have a huge data, you still have the same amount of data being transmitted over the network, the same amount of data that is being read, which is going to take time. So because of this reason, RC file format is something which is not used much. Next comes an ORC file format, the optimized roof columnar. So ORC, you can ORC file format in some ways you can say is basically an extension of an RC file format. It's optimized row columnar file format. It is again a columnar file format. So the great good thing about this, or the great feature about this, is it can compress the file up to 75%. So it has 75% compression ratio. So that means we can compress the original file up to 75%, which is huge, right? With so much of data going around, that compression ratio is really going to help in saving the data, right? Saving the storage. Now with that compression ratio, whenever you want to read the compressed data, the first thing that you have to do is you have to decompress it, and then it is going to be read. Now decompressing 75% of, I mean, now decompressing this huge data might take time. So basically ORC use when you're dealing with historical data. It's not something that you're using regularly. So if you have, let's say, 100 GB or 1000 GB of data and you compress up to 75%. Now, in order to read that, when you are querying the data, it has to decompress all those 1000 GBs of data. So it is going to have a bit of lag, right? So now if it's something that you are going to query every now and off and every day, if you have to query 1000 GBs of data, ORC may not be the right format for you. But again, if this is something where you are storing historical data, or something that you are not going to query every single day, then yes, it's a better option where you store the historical data and you query the data once in a while or troubleshoot some things. Then ORC would be a good file format for you. Then comes the Avro file format. It is basically a raw file format. So as we seen in the previous session, when you use a raw file format, it is easy to write because you just add the data at the end of the block, right? So reading is again tough because data is stored in rows, and whenever we query the data for different columns, it has to go through each and every block. That is something that we have seen in the previous session. Because in big data, it's not transactional, it's more of aggregation. So this is something which is you know which is difficult because in big data we do more of aggregations or more of OLAP queries, so we don't do the transactional. So Avro is something which is going to take a lot of time for to get the data onto the system when you query the data. But so, but why did I say that this is kind of one of the widely used file formats? If it is a raw format, and we basically in big data are looking more on the aggregates, why use Avro file format? So Avro file format supports schema evaluation. So what that means is, let's say you have a input data. So your input data, the structure is keep on changing. Let's say today you have 10 columns, tomorrow you have 12 columns, maybe another couple of days later you will add three more columns. So your key schema is keep on changing. So what happens with that is there's a lot of backend changes that you will have to do if you want to you know accommodate the newly created schema or newly changed schema. But Avro supports this brilliantly. So you have something called as an AVSC file, .avsc file. That's where you store the schema. So anytime you want to make changes to the schema, you don't have to touch the code. You just go to that particular file, you add whatever the columns you want, delete whatever the columns you want, and the data that comes up after that, it is going to read the data according to the new schema that is present here. So this is really great. So whenever you have a schema which keeps on changing, then Avro file format is a great fit for you. Then we have Parquet file format. So Parquet file formats are based, it has its own compression technique as well. So Parquet file format has its own compression techniques, but it has a little bit less compression compared to ORC. But Parquets are great for nested data. So if you have nested data, then the Parquet file format is great. So in the world of Spark, where you're using Spark, you will see a lot of projects using Parquet file format predominantly, because you have to work with nested data, you have to work with complex data. So Parquet file format is something which is widely used. ORC is something which you use for Hive in most projects, right? And Avro is basically when you have a schema that keeps on changing. So these are the file formats in the big data, and as I mentioned earlier, ORC, Avro, and Parquet are the predominantly used. Even in the interviews, you will hear only about this. Sequence and RC, I would suggest you don't have put too much stress on them. Understand that there are these are the file formats that are there and their features, but concentrate more towards ORC, Avro, and Parquet file format. So this is a very famous picture you will see in almost most of the courses. So this gives the file comparison across RC and Parquet and ORC. As you can see, the original file was 585 GB. So with RC, it came down to 14%, but with ORC, if you see, it came down to 131 GB. That's huge, right? From 585 to 135, 78% smaller. Then you have this Parquet file format, which is not that great as a ORC, but it's right up there. It has 62% of compression, and it came down to 221 GB, right? So that's where we are on the file formats. Now, just to summarize the ORC, Avro or Parquet file formats. So, Avro is row format, ORC and Parquet are columnar format. Avro is write heavy because it's a row format, it's write heavy, and ORC and Parquet are read heavy because they have to decompress the data, the and so that is going to take some time while reading the data. Now, in all these file formats, what happens is along with the data, the schema will also be present somewhere, right? So this means you can basically take these files from one machine, you can load it into the another machine, and with some queries that we will see at a later part of the course, you will be able to read the data, you will be able to read the schema because the schema is embedded within that file. So that's one great feature of these file formats. All these file formats basically can be split across multiple disks. So scalability, parallel processing is something which is never an issue with these file formats. And as we have seen in the previous screenshot or the previous pictures, ORC provides maximum compression followed by Parquet. Now, if the schema of your data keeps on changing, then Avro is the preferred method of file format. ORC is also supposed to some extent, but then Avro is superior in this aspect. So, if you have a schema changing, we go for Avro. So, where are these used? So, Avro is basically used in streaming apps like Kafka. Parquet is commonly used in Spark, and ORC in Hive. Because the compression technique of ORC is more, it is used for space efficiency. If you want to save space, you want to compress as much as possible, you use the ORC file. Query time will be a little bit more because it has to first decompress the data before showing onto the screen. So if your query time is not an issue, if you are okay to have that lag, then yes, you can go with ORC file format. But in case of Avro, the time efficiency would be good. It takes less time to decompress. But if you want to space, as I mentioned, if you want to save space, you use ORC. If you want to save time, then again, this is on the columnar format. You use Parquet because Parquet has less compression compared to ORC, and it can work easily with the nested data. So that's where Spark application, most of your Spark applications uses Parquet, while ORC is predominantly used in Hive. So this is an example of a Avro file that I had on my system. Now, if you can see here, right, the first line of code, right? So this is the schema. So this is the schema. You have the schema, then you have the data, and this is a Parquet file. You will have schema somewhere here. You have the data, which is not readable format, right? Both ORC, Avro, and Parquet, they are not readable format. This is the ORC. It has the biggest level of compression. You can see it right here. It mentions ORC. All these are in unreadable format. You will have to decompress the data to read them. In our coming sessions, we will read each of these file formats. We'll read it in Hive, we will read it in, import using scope, we'll read it in Spark, so we'll have better understanding. But I hope this was clear and you had a good understanding of how the data is stored in row format, how the data is stored in column format, what are the disadvantages and advantages of each one of them, when to use a row format, when to use a column format, what is serialization, what are the different file formats that we have, serialized file formats that we have, and what is predominantly used and where it is used. So this is a very important topic, especially when you want to start a new project at architecture level. You want to see what file formats you want to use for a particular use case. Also, from the interview perspective, this is kind of a questions that you will definitely be asked. So, do go through the video one more time if something is not clear, and if you have any questions, please feel free to get in touch with me on the Q&A, and I will try to answer as early as possible. So thank you so much for listening to this session, and I'll see you guys in my next class.